Hey, hello everyone. So today we are going to solve LeetCode 572, which is a subtree of another tree. I've chosen this problem because it is an interesting one, irrespective of shown as easy. Because even if it is marked as easy, I do think it should be categorized under medium. And considering this, let's jump into the question. So given the roots of two binary trees, root and subroot, return true if there is a subtree of root which with the same structure and node values of subroot, and return false. So what it's saying basically in summary is that we have this tree which is root and we have another tree which is called as subroot. So you have to just say that the subroot is a part of the root. So subroot here 412 is part of root, yes. So in this case we have to return true. All right. And now again, the second example is that we have been given a root 3, 4, 5, 1, 2, 0, and there is subroot 4, 1, 2. So is this part of this tree? Not truly. I mean, even the 2 has a subchild, but here the given root, subroot, the right child of 4, which is 2, doesn't have any further child. So basically, this is not the case, and it should return false. So this is kind of validating, looking and matching the values of the subroot tree with the values of the root tree, and then we have to return true and false. So if you look into the question closely, it is kind of that all right, so this is root, this is subroot. So initially looking into the logic, we will just see that whether this is matched, if this is not matched, so either it would be on the left side or it would be on the right side, this subroot root node, right? So there will be condition traversing either onto the left or onto the right. But once we have found the root as to be 4, so now we understood that this could be the desired answer. This could match the subroot structure and we have to return true in that case. So we have to compare and validate both of the left and right part of this root node. So now here it was either this or condition. Here it is this and this. So the validation of each left child with the left child of subroot, and the validation of each right child with the right side of the subroot node. And once all these values are being matched, we have to return the left and right, we have to return true. And once this part is returned as true, we have to return true as the output of the outer call. So this, looking into this problem, clearly suggests that there is a different function being created which helps in validating the values of the root nodes of subroot and this child node of this root node. And there is an outer function which calls it either on the left side or on the right side. So coming back to the solution, so here we have this problem, and the solution will look something like this. We have this root and subroot. So we are going to see that first of all, if root is null, if the given root is only null, based on base conditions of a recursive call. So if the root is null, and if the root is null and the subroot is not equal to null. So the root is null and subroot is not null. Basically, we have to return false here. All right. And there's a second condition: if root is not null but subroot is null. If root is not equal to null and subroot is equal to null. So in this case, if root is not null, subroot is null, so we can, there is no subroot to verify, so we can return true. Or if both are null, then also it is true. All right. So this could be an nested condition, or we can say that root is equal to null and subroot is also equal to null, and both are null, then we have to return. If both both are null, then we can return this true. Yep. All right. So these are the some base conditions of this recursive call. So this is how it will go. This is the condition being closed. Root equal to null and subroot not equal to null. False, return true. Now, the condition is true that we have some valid given this irrespective of null condition. So here I will just think of a method being called, which basically suppose I'm considering that the root is also 412 and the subroot is also 412. So I have to call a method which just verifies the left and right accordingly the values and just give me the result on the comparison of the values. So if I will call this as a valid method if is same tree, if it's same tree, if subtree, if it's same tree. So if it's same tree, here I will pass root comma subroot. Then if it is true, then just please return true. All right. And now my new method will be somewhat same as this name. If it's same tree node, suppose call it P and call it Q. And I have been passed this. I have passed this parameters at root and subroot, and I need to check whether it is the same or not. What is the criteria of being same? So I have to see that whether first again the base conditions that if P is equal to which is null, and if P is null and Q is null in this case, so if both are null, we already know that we have to just return true. And coming back to the other condition that if P is not equal to null and Q is equal to null, P is not null, Q is null, or I mean P is not null, Q is null. So now this is not the case. Okay, now since we have already passed it from the upper validation and we are again validating that this is found that P is not null and Q is null, and this is happening, these are a lot of if else conditions here, so that is the tricky part of this game. Or if I'm checking that P not equal to null, Q null, or P is equal to null, Q not equal to null. P is equal to null and Q not equal to null. Q not equal to null. So this is the condition. Or we're closing this. Or P dot val is not equal to Q dot val. So it is not equal. What we are expecting, it should be equal, but it is not equal. So just return false. If any other comparison is not equal, it is false. Return false. And if it is true, the matching is true and the P and Q is not null, it means we are going on the right path. And when will be the P and Q null? If in case that all the P and Q is being matched and it comes to the leaf, leaf child of the null child of the last leaf node of P and Q both as well. So in that case, we'll see that all has been traversed and this condition has not been fulfilled. It means the actual answer is true. So now these are two other base conditions, and I will just call the recursive call where if it's same tree, P dot left comma Q dot left, either this is true and not either, both of these are true. Left part is also equal and right part is also equal. And P dot right comma Q dot right. and we have to just return this. So this comes to be true, all left are equal. This comes to be true, all right are equal. So all right, calling this method is same tree. So now it checks that all left is equal, all right is equal. Why is it showing error? T dot right, comma, Q dot right, tree. Okay, either this or this, right? Okay, yeah. So if this is true and this is true, it will basically return me true. And this is considering the case whether in the case where the root node is the same as the subroot node. So there is a possibility, as an example 1, that the root node is on the left part of the actual root node, which is 3. This the root node of subroot is on the left part of the root node of the given example. All right, so this is on the left part, not on the right part. So here it could be on the right part also or on the left part, but it is not as the same as the subroot structure. All right, so given the root would have been 412 and the subroot is also 412, it would be easier flow. Now this is done, but we see here that the 412 is on the left part of the given root, which is 3. So here we have to check whether it is on the left side or on the right side, and if it is found on the left side, now this will be the condition being called. So we have to return calling of its subtree here, root dot left comma subroot, or here it is being called as is subtree root dot right comma subroot. So either on the left part of this this is subtree method, or on the right part. So we have to just return this. What is the issue here? The method subtree is undefined for type solution. So its subtree is this, and root dot left subroot, root dot right subroot, and yeah, I think it should work. Okay, this is the issue. I'm trying with this camel case structure, and this is this one. Alright, so yeah, I think now it is good to go. Let's run and see whether this error is being resolved. So this is how I think there is some slowness in internet. So this is how this problem is being solved, considering these many cases, and uh, looking into the problem closely, that it could be on the left side or on the right side. But if one found the both left and right, so or and interpretation is all basically what it gives you, the accuracy of moving and traversing inside the tree, and checking out various if else conditions further to validate the base cases of this recursive call, which could be true or false. And if it is true, always it will keep on traversing and on the left and right part of the subtree. So this was the solution of the subtree of another tree, LeetCode 572. See you in the next problem.